colleagues, innovator, fellow pioneers in the field of science, technology, nursing, and medical science. I'm very thankful to NextGen Tech 2024 conference Eudoxia organizing committee to this opportunity. This is Mahesh Vaijainthymala Krishnamoorthy from Dallas, Texas, USA. Currently, I'm working as a senior consultant software architecture for Dell Technologies. I'm an independent researcher outside of my work, AI ML developer, advocate, and practitioner. I have 16 plus years of experience in the IT industry. So the scheme of this presentation is transformative innovations in science, technology, nursing, and medical science. My topic is AI's revolutionary impact, transforming medical science and technology. So let's get into this. What's happening here, actually? So the thing is, we stand at a moment in history where artificial intelligence is not just enhancing our capabilities, it's fundamentally transforming how we approach healthcare and medical science. Today, I'll share with you some groundbreaking developments that are reshaping our field in ways we could only dream of a decade ago. The convergence of AI with medical science represents perhaps the most significant technology leap since the discovery of antibiotics. We are witnessing not just incremental improvements, but a complete paradigm shift in how we prevent, diagnose, and treat diseases. The convergence of AI with medical science represents perhaps the most significant technology. But a complete thing is, I would like to share my perspective both as a researcher and as a practitioner in this field. Um, Drawing from my recent work on privacy preserving AI and human-centered governance systems. What makes this moment particularly exciting is how AI is simultaneously solving long-standing challenges while raising important new questions about privacy, ethics, and human oversight. So the evolution of AI in healthcare currently. So here, Mayo Clinics, the researchers have developed groundbreaking AI systems that can predict heart disease from ECGs with remarkable accuracy. Their system can detect left ventricular dysfunction, even in cases where the ECG appears normal to experienced cardiologists, demonstrating how AI can enhance rather than replace human expertise. So it is kind of no early detection capabilities. The AI-enabled ECG system can detect heart condition before obvious symptoms appear, with particularly strong results in identifying. So it is the accuracy, right? The accuracy rate is kind of 96 and 97. It is really remarkable. The left ventricular dysfunction with accuracy rate, it is really remarkable. Atrial fibrillation with an accuracy of 83.3% and AUC score of 0.90. This is completely marvelous. Hidden patterns of coronary artery disease years before, like traditional detection methods, going throughout the paradigm shift where they could not actually do prior to the condition appears, actually. So here, that is what they have. Actually, the clinical applications, they have created smartwatch integrations. The technology has expanded to consumer devices, with Mayo Clinic developing an algorithm that can detect weak heart pumps using Apple Watch ECG data, making sophisticated diagnostics more accessible. The multiple disease detection is also possible. The system can identify various cardiac conditions, including amyloidosis, aortic stenosis, hypertrophic cardiomyopathy, pulmonary arterial hypertension, and this kind of the performance metrics. The AI system demonstrates exceptional accuracy, can analyze over 66 discrete diagnostic ECG codes with ROC curves greater than equal to 0.98. For 62 of them, achieves sensitivity rates of greater than 95% across all diagnostic codes, actually. So they outperform cardiology residents in recognizing 6 types of ECG abnormalities with F1 score above 80% and a specificity over 99%. The clinical impact, actually, the clinical impact is like, no, the implementation has shown significant practical benefits, enables early intervention before symptoms become apparent, provides cost-effective screening through standard ECG equipment, allows for continuous monitoring and risk assessment. This technology represents a transformative approach to cardiac diagnostics, combining the accessibility of ECG testing and the power of artificial intelligence to detect heart conditions earlier and more accurately than ever before. So next, Memorial Sloan Kettering Cancer Center, they call it as MSK, has pioneered a transformative developments in AI-powered pathology analysis through the Warren Alpert Center for Digital and Computational Pathology. So AI system are analyzing pathology slides at a scale and speed previously unimaginable. They examine hundreds of tissue samples in the time it takes a pathologist to analyze one, while maintaining remarkable accuracy rates above 95%. So scale and infrastructure in their thing. MSK has built one of the world's largest digital pathology database, includes over 44,000 digitized glass slides, images from more than 15,000 cancer patients, a comprehensive library of 25 million pathology slides, over 5 million whole slides representing patients globally. So the performance metrics, what they have achieved, the AI system demonstrates exceptional capabilities. Nearly 100% accuracy in detecting cancer-containing biopsies, 70% reduction in diagnostic errors when pathologists use AI assistance. So it's a remarkable percentage. Ability to analyze prostate, skin, and breast cancer samples with clinical grade accuracy. So the efficiency gains, what they have achieved, right? The implementation has shown remarkable improvements in workflow. Pathologists reading list, the time reduced by 55% from 129 seconds to 58 seconds per slide. Automatic quality control ensuring clear, focused, and debris-free slide images. Ability to process massive data sets while maintaining accuracy across diverse patient populations. So their clinical impact has created, the system has transformed pathology practice through shift from qualitative to quantitative analysis. Integration with other diagnostics data, genomics, proteomics, radiographic imaging, and so on. So enhanced ability to detect subtle patterns that might be missed by human observation. So this is kind of a real achievement. This technology represents a significant advancement in computational pathology, enabling faster, more accurate diagnosis while allowing pathologists to focus on complex interpretative tasks, rather than routine screening. So, right, this is one of my research paper which I have developed, and it is under review. So this the privacy and ethics in medical AI, which is required at this moment because the AI is evolving. So how these advances, however, bring us to a critical challenge. How do we maintain patient privacy while leveraging the full potential of AI in healthcare? Several approaches have emerged to address this challenge. Stanford's federated learning system allows hospitals to collaborate on AI development without sharing sensitive patient data. MIT's researchers have developed differential privacy techniques specifically for medical imaging. Building on these foundations, my research explored a novel approach called a latent space projection. This technique enables healthcare institutions to maintain both privacy and utility in their AI systems. When implemented at a regional hospital network, this approach can help them maintain diagnostic accuracy while providing robust privacy protection. But we are not alone in this pursuit. Microsoft confidential computing framework for healthcare and Google's privacy preserving machine learning tools represents parallel innovations in this space. Together, these developments are creating a more secure foundation for medical AI. So in our system, what latent space projection network diagram. First, the encoder transforms the medical image into what we call latent space representation. Think of this as a creating an abstract essence of the image where different types of information are naturally separated, much like how oil and water separate when mixed, actually. In the middle layer, which we call the protected latent space, the system maintains two distinct types of uh, information: the diagnostic features necessary for medical analysis and the sensitive patient identifiers that need protection. The breakthrough here is that can mathematically ensure these maintain separate while preserving remain separate while preserving the relationships critical for accurate diagnosis. Finally, when the data needs to be used, say for analysis, say for training an AI model or making a diagnosis, the decoder reconstructs only the necessary medical information, leaving the sensitive patient data protected. In our breast cancer diagnosis trials, this uh, 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 diagnosis approach us to maintain diagnostic accuracy above 98% while providing robust privacy protection. You can see the federated other learning methods, other privacy methods, where raw data has 99.2, where it all has the accuracy of 94.5, so on. So we have achieved 98.7 in our LSP method. So here, the performance actually. What's remarkable is that unlike traditional anonymization methods that often degrade image quality or lose critical details, LSP preserves the subtle features that can be crucial for accurate diagnosis. This means healthcare providers can collaborate on AI development without compromising either patient privacy or diagnostic accuracy. So this helps in compliance with the GDPR and HIPAA compliance, where they can use AI system with their compliance mechanism. So next, what I've preferred is human-centered AI governance, which is required in the ethical AI and responsible AI development. So I have done a research on enhancing responsible AGI development, integrating human in the loop approaches with blockchain-based smart contracts. The question of governance and oversight has become equally crucial, actually. The Cleveland Clinic has pioneered a human in the loop system for radiology AI, where algorithms and radiologists work in concert. So on. This brings to me to my second major research contribution: the integration of a human in the loop approaches with blockchain based governance system. Consider this real scenario. We encountered a major hospital network implemented an AI system for prioritizing emergency department cases. While highly efficient, they needed a way to ensure ethical oversight without slowing down critical decisions. Our blockchain-based governance system, detailed in my 2024 paper in the Journal of Advances in Mathematics and Computer Science, provided a solution. We implemented a system where AI makes initial assessments on the patient's data, uh, where the smart contracts automatically trigger human oversight when needed, only when needed. Until then, the confidence score is based on what confidence score we reach. If it is above 80%, it will actually go on. Maybe above 90%, it will go through the proper process and it will complete the diagnosis and allows it. If it actually goes below 80% or 90%, it has to actually trigger an oversight mechanism where it will ask the expert doctors, nurses, and many other people, right? Who all we are consolidated them as an experts in the system. It will trigger an oversight where it has actually reach them, and they will analyze. And if that is properly diagnosed, they will actually approve. Otherwise, they will send it for a reconciliation. So smart contracts automatically trigger human oversight when needed. All decisions are recorded immutably for accountability. So every decision is precious, actually. So a diverse panel of experts provides ongoing guidance all the time. The results were remarkable. Emergency response times improved by 33%, while maintaining 99.98% system uptime and a mere 0.2% ethical violation rate. Our team's work on blockchain-based governance system builds upon these foundations, adding transparent accountability to human oversight. This approach complements IBM's AI Fairness 360 toolkit and Microsoft's responsible AI guidelines. Let me. There are, there are several case studies that we can actually discuss, but there are. You can look into the data and you can analyze it with the paper centered on the AI governance mainly. So the future directions, actually, what we have to cover is like personalized medicine, predictive healthcare, accessible healthcare for everyone, right? So Stanford's AI-driven treatment personalization has shown a 35% improvement in patient outcomes. So in predictive healthcare, Beth Israel Deaconess Medical Centers AI system now predicts potential patient complications 48 hours earlier than traditional methods. Accessible healthcare in India, Google Health's AI-powered diagnostic tools are helping some kind of tools helping rural clinics provide specialist level care. Collaborative AI. The UK's NHS is pioneering a nationwide system for AI collaboration while maintaining strict privacy standards. Conclusion here, the future of healthcare AI lies not in any single innovation, but in how we integrate these advances to create systems that are both powerful and responsible. From privacy-preserving techniques to human-centered governance, from automated diagnosis to personalized treatment, we are all contributing pieces to this complex puzzle. Together, we are building a healthcare future that's more efficient, more equitable, and more human-centered than ever before. Thank you so much.